Day 226 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 226 and we're still going strong, y'all. Today we have question number 100, same tree. The difficulty level is easy, but don't worry, you already know we're going to keep the solution as simple and easy to understand as possible. And guess what? Today I got two different solutions for y'all, so I hope y'all are excited about that. So let's see what the question says. Question says, given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So let's break that down. Let's look at example one. In example one, we have the input P. It's a binary tree, 1, 2, 3. Then we have Q. That's a binary tree as well, 1, 2, 3. The output is true. So the output is true because as we can see between these two binary trees, they are exactly identical. So they are structurally identical, meaning they have a root node. They each have a root node right here, and they each have one left side or left subtree node and a one right subtree node, right? And same on this side, one left subtree, one right subtree. And the nodes have the same value. So both root nodes have a value of 1, and both left subtrees have a 2. It's a 2 on both sides on the left side, and it's a 3 on both trees, on the right side. So that's why that's why they're considered the same, right? And you can see by looking at the input, they look identical too, like 1, 2, 3, P equals 1, 2, 3, Q equals 1, 2, 3. So that's an example of when they look the same. Now let's look at example 2 where they are different and they might try to trick you, right? So in example 2, we have the input P equals 1 and 2, or equals a binary tree 1 and 2. Q equals a binary tree 1, null, and 2. The output is false. Now we can tell just by looking at these two trees that they're not the same, because this is 1 and 2 and this is 1, null, and 2. Now let's break that down as to what the difference is, right? So on this first subtree, 1 and 2, we have the root node 1 and we come to the left side of 2, right? Boom. So it's just 1 and 2. Now remember, these read from left to right. So on this side, we have the root node 1, which is the same, but then we come down to the left side and it's null. It's nothing right there on the left side, so we have to put a null right there. Whereas on this side, we didn't have to put a null on the right side, because that's the end. Since we read from left to right, we don't have to put a null. But since we read from left to right on this second subtree, we have to check the left side first before we check the right side. So on this side, on this second binary tree, we are checking. We see it's the 1, then we check the left side. It's nothing there, so we return null, but we still have to check the right side, because the right side holds a value, which is a value of 2, whereas this side, the right side doesn't hold a value, so we can just stop. On this side, we can't just stop after null after checking the left side, because the right side actually holds a value, which is 2, which is why it goes 1, null, 2. And being as though this has a left subtree and this does not have a left subtree, and this does not have a right subtree, but this does have a right subtree, 1, they are not structurally the same, and 2, the nodes hold different values, right? This left subtree holds a value of null. This left subtree holds a value of 2. This right subtree holds a value of null. This right subtree holds a value of 2. So that's why the output is false, because they're not the same. Now let's look at example 3, one last example where they try to trick us again. This time the input is P equals a binary tree 1, 2, and 1. Q equals a binary tree 1, 1, and 2. Now we can tell once again that they're not the same just by looking at the input. This is 1, 2, 1, and this is 1, 1, 2. But let's look at the picture so we can break it down, right? And it's pretty much the same thing. We read from left to right, right? So we do the left subtrees first. That's why it goes 1, which is right here. Then we have right here 2, which is on the left side, which is 1, 2. Then we read the right side, which is why it goes 1, 1, 2, 1, just like that. Boom. Then we check this one. As you can see, this left subtree has a value of 1, this left, this binary tree, this binary tree has a left subtree of a value of 1. This also has a right subtree of a value of 2, which is why it reads 1, 1, 2, right? It goes 1, 1, 2, because we have to read it from left to right. We start with the left, 1, 1, 1, 2, right? And as you can see, those are different because even though it's structurally the same, the values are different. And like it says up here, the nodes must have the same value. In this case, the nodes do not have the same value, even though it's structurally the same. This node has a value of 2 over here, and this node has a value of 1 over here, right? And same on the right side. On the right side, this subtree has a value of 1, and on this binary tree, the right side has a value of 2, right? So that's why it's different. That's why the output is false. So now that we understand the question, let's get into the solution. But before we get into the solution, y'all, don't forget, if you need any new Apple AirPods, go ahead and check out that link in the description. Then after you check out that link in the description, go ahead and like, comment, and subscribe for me, y'all. It is appreciated. Now, let's get into the actual code. Code is not that difficult. It's not that long either. First thing we're going to do is we're going to use excuse me, y'all. Remember, I got 2 solutions. This is the first solution, so let's go through it. First thing we're going to do is use a guard statement to check if either or both of the nodes P and Q are nil, right? So we're just going to say guard let P equals P, comma, let Q equal Q. Then we're going to say else, boom, else, open up the brackets. We're going to say return P equals nil and return Q equals nil. So if either P or Q is nil, we're going to return true only if both are nil. Both trees have reached the end of the we've reached the end at this time, at the same time, right? So we need to make sure that that either P or Q, they both have to be nil. If they're not both nil, then we'll know to return false, right? So remember, this is going to return a Boolean, either true or false. So that's how we're going to know if we're going to return true or false. Then we're going to come down here, and just in case, that's just the guard statement. Now it's time to compare the values of the current node P and Q recursively. So we're going to use some depth first search recursion, and if the left subtrees of both nodes are the same, we're going to check to see if the left subtrees are both. We're going to check to see if the left subtrees of both nodes are the same, and we're going to check if the right subtrees of both nodes are the same. And in order to do that, we're going to say return p.val equal sign q, q.val. And remember, this is a Boolean. It's going to return true or false, right? That equal sign. Then we're going to say and. This is where the recursion comes in. We're going to say is same tree. That function from right up here. We're going to say p.left. Then we're going to say q.left. And once again, this is going to check if the left subtrees of both nodes are the same. Now we have to do it for the right side. We're going to say by saying and, then we're going to say use some more recursion. Excuse me. 2 and signs. Then we're going to say is same tree. Open up the parentheses. This time we're going to say p.right, comma, q.right. And now that should be all she wrote, y'all. Let's run it. See how it runs. Make sure there's no typos. Oh, look, see, we got a typo already. So let's see what it says. Expected. So it says error, expected expressions after operator. Oh, sorry. We don't have to say return twice. That's my bad. We only had to say return once. My bad, y'all. Let's run it again. Let's see. And it's accepted, y'all. So let's submit it. See what it's looking like after we submit it. Okay, but, boom, 0 milliseconds beats 100% of users with Swift, y'all. You already know that's faster than a Bugatti riding past Andrew Tate and the rest of the brokies. Now, let's start this. Let's clear this. Let's get into the second solution. You know I had to throw a second solution in, and you know why I had to throw a second solution in? Because guess what? We got a one-liner. Y'all know I had to find a way to get my one-liner in there. So let's get to it. First thing we're going to do is we're going to check if both nodes P and Q are exactly the same in the object memory. And we're going to do that. We're going to say, open up the parentheses. We're going to say P. Then we're going to say equals, sign, 3 equals sign, equal to Q. Right? And what that's going to do is, if true, the trees are the same at this point, and that means both are either nil or the same reference. So then, but we're not done yet, because now we're going to say or, but that's just going to check to see if P and Q are the same, right, at this point. But if not, we still have more to do. So first thing we're going to do, we're going to open up the parentheses. We're going to say P question mark dot val. Then we're going to say equal sign Q question mark dot val. And so we're going to see if the values of P and Q are equal, and we're just going to they're optional, so we got to throw that question mark in there, right? Now this is where that recursive comes in. We're still using recursive, we're just using it one line this time. So we're going to say and, we're going to check to see if the left subtrees P and Q are the same and the right subtrees P and Q are the same, like we did up top. Or not up top, but like we did last time. So we're going to say is same tree, open up the parentheses, P question mark dot left. Then we're going to say comma Q question mark dot left. And that's going to see if those are the same. Then we're going to call that one more time for the right side, and we're going to say is same tree. Boom. Open up the parentheses. This time we're going to say P question mark dot right, comma Q question mark dot right. You know I had to get this one-liner in, one line of code. Let's run it, see how it runs. Fingers crossed. First try, and it's accepted, y'all. Look at that. So let's submit it. See what it looks like after we submit it. Oh yeah, we're on a roll today, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. You already know we riding fast in our Bugatti past all the brokies, y'all, because we Swift programmers, and that's what we do, y'all. So I hope y'all learned something today, and I hope to see y'all here for another day, another LeetCode problem. We'll be here tomorrow. See y'all then.